What do you think of? Okay, and what does optimize mean to you? Oh, most efficient. I like that. So if we're talking about money, like you making money, you would want to like maximize your money, right? If we're talking about the cost of something, we all would like to minimize cost, right? So I like your word of efficient. Sometimes being efficient means we want a maximum of something. Sometimes being efficient means we want some sort of minimum, okay? What we are going to do is something called linear programming. And it's basically a way for us to set up some inequalities and use those inequalities to make a decision about some sort of optimization, whether it be maximum or minimum, okay? So in order to do that, okay, we're going to get a scenario. And with that scenario, we are going to write an objective quantity. So write the objective quantity, the quantity to be maximized or minimized. Kind of forgot I changed the blanks there, okay? So the quantity that's going to be maximized or minimized. This is going to be separate from what we are going to do next. Okay. All right. A little off there with my. Okay. Next, you're going to set up your constraints. These are just inequalities. Okay. Just like you did in last night's homework, you're going to take some scenarios and create inequalities out of them. Okay, these are what we call constraints. Okay. You are then going to graph your constraints. Okay, just like you did yesterday in your homework. What do you think the find is going to be? Yeah. You are going to find your vertices or vertex points, however you would like to call them. Okay, so right here, this is everything that we did yesterday. Okay, but we have a step before, set up the objective quantity. What are we minimizing or maximizing? Okay, well then we're going to take those vertex points and we're going to plug them in to the objective quantity so that we can make a decision based on maximizing or minimizing. Okay? Which vertex gives us the biggest objective quantity? Which vertex gives us the smallest objective quantity? So, not a lot different than yesterday. We just have a step in the beginning and a step at the end that we need to add to this to bring in this maximizing and minimizing. Okay. So your first example, I already have graphed for you on your paper. Okay, and I kind of color coded it up here. So the z equals 3x plus 2y. That's the objective quantity. Notice how I'm still using the variables x and y, but it equals a different letter, okay? You'll see when we get to our word problem example, sometimes I'll make this like P for profit or C for cost, okay? It really doesn't matter what it is. It's just something besides x and y, all right? And then it looks like we have 1, 2, 3, 4 inequalities graphed here, so we have this region. Okay? So in this problem, we have the objective quantity, that's step 1. We have our constraints, that's step 2. I've graphed them for you, that is step 3. What's step number 4? Find the vertices. Okay, so you need to help me out with this. many vertices does it look like we have? I see some 4s going up. I think it's 4. We have 1 right here. That's the corner, right? That's an intersection point on my boundary. What coordinate is that? Okay. Here's an intersection point on on the shaded boundary. What coordinate is that? Okay, we can tell that, right? This is an intersection point along the boundary. What is that? 0, 2. Okay. And then this coordinate right here. It appears to be 2, 1. How could we be for sure? Okay, this is the intersection of green and red. So here is my red. Let's make it an equation. 2 plus 2 times 1. Does that equal 4? Okay, here's my green equation. 2 minus 1 equals 1, right? Okay, so luckily our graph was nice and we got to save us a step of having to do the algebra. Okay. Now what we get to do with it is we get to come back to the objective quantity and we get to plug each of those vertices in. Okay, so let me maybe do this. Okay. At 0, 0, if we plug that into our objective quantity, we get 3 times 0, is it plus 2y? Plus 2 times 0. 3x plus 2y, what does that equal?
5. Way down 0.
It's okay, we're still waking up. How about when we plug in 1? 3x plus 2y would equal 3. Okay. The new part is actually the easiest part of the solve, right? Okay. All right, our objective quantity, 3x plus 2y, when we plug in the vertex of 0, 2, would give us okay, and then 3x plus 2y plugged into the objective quantity would give us what? 8. Now we make a decision. If I asked you for the minimum, what is the minimum? 0. We have a minimum of 0 at the coordinate 0, 0. What's our biggest number up there? 8. So we have a maximum of 8 at the coordinate 2, 1. And that's how we make our decision. Now, in this one, we found both the minimum and the maximum. Sometimes I will say one or the other, okay? What do you think? Like one extra step, right? Take the vertices and plug them into something to make a decision. Right? Go ahead and take a look at the next example, all right? Once again, I have the objective quantity written for you, and I have a list of constraints written for you. So I've taken care of steps 1 and 2. What we need to do is we need to graph the constraints. Okay? So I'm going to go ahead and I'll color code once again up here. Okay? And if you need a color code, you're welcome to, or at least label on your graph. So x plus 2y equals 4. What would the x-intercept be there?
4.
Okay. And what would the y-intercept be?
2.
Okay. So that's the line x plus 2y equals 4. Okay. I'm going to label that in case I need to do an intersection later. Oh, which way would we shade on that one? Does 0, 0 satisfy it? Yeah, no? What? No, it doesn't satisfy it. So we would want to shade away from 0, 0. So I'm just going to make that note. All right, my next inequality, what would be our y-intercept? 7. Now, we don't really get a nice x-intercept, do we? Okay, so if we want to subtract the 3x over, we know that we would have a slope of -3. So if you'd like to graph it that way, you're welcome to. We don't have to use the same method every time. Okay, does 0, 0 satisfy that inequality? Oh, Mrs. Homan, what did I just do? What kind of slope did I just graph? I graphed positive slope. That's why we work with pencils, right? This better? There's a -3 slope. Okay. So going back, does 0, 0 satisfy? It does not. We would have to shade away. And then my red line looks like it's going to have an x-intercept of -7 and a y-intercept of 7/2. That's our line, -x plus 2y equals 7. Ooh, how about this time? Does 0, 0 satisfy? So it looks like our overlapping shading is right in here where all of them would intersect. Okay. What's different about this graph than the last graph?
On ours it says y is greater than or equal to 0. On paper.
Oh, on this one?
Yeah.
It does? Ooh, I forgot about that. It does. Which means down here is not shaded, right? I forgot I added that in. Thank you. Y is greater than or equal to 0, which means we have this guy. And we're only right here. Okay, there's a reason I did that. Do you notice how graph number 1 was a closed area? It was a bounded region. Is this shading all closed in? It keeps going, right? Okay. That's going to be important here in a little bit. So we have 3 vertex points. We have an intersection here along our shading. We have an intersection here along our shading. We have an intersection here along our shading. And if you did a nice, precise job with your graph, we might be able to avoid algebra for our vertices on this one. Okay? All right, so let's list our vertices. Okay? We know this one for sure because we used it to graph. What is this one?
40.
That's the coordinate 4, 0. Okay? This intersection, what does it look like? It looks like 2, 1. Please make sure that that is actually true. So this is the intersection of green and blue. If I plug 2, 1 in for green, it's 3 times 2 plus 1 equal to 7. Is 3, wait, no, is 2 plus 2 times 1 equal to 4. Okay, then 2, 1 is legitimately our intersection. Okay. I feel like we did a pretty nice job graphing these two lines also. What does this coordinate look like? It looks like 1, 4. I have no problem with you using the graph as long as you check it. 1, 4 is 3 times 1 plus 4 equal to 7.
Yes.
Okay, is negative 3 plus, is negative 1 plus 2 times 4 equal to 7?
Yes.
Okay, so 1, 4 is that intersection. We're okay there. Okay. Go ahead and take 1 minute and plug those into the objective quantity. Z equals 4x plus 2y. I'll do my work, you do your work. Okay, I'm getting 16 for 4, 0, 10 for 2, 1, and 12 for 1, 4. Okay.
Which equation did you put that into?
The objective quantity.
Yep, sorry.
Nope, that's okay.
I was trying to plug it into one of the inequalities.
Oh, yes, that probably didn't matter. So let me ask you a question. What's our minimum? What's our maximum? I disagree. Our shading keeps going, right? So those coordinates are just going to get bigger and bigger and bigger and bigger. And so we actually have no maximum because we have an unbounded region that grows in the positive direction. Yeah. Oh, I'm sorry. Yeah. There you go. I wrote the 10 down and then I grabbed the wrong coordinate, didn't I? So there's no maximum because we keep growing. If we were growing in the negative direction, we wouldn't have a minimum. Now, the first couple problems in your homework are going to be like this, where we have the objective quantity already written, we have the constraints already written, all you have to do is graph it and make decisions. Okay? Now, what I'm most concerned about is us being able to take a scenario and actually write the problem ourselves. So go ahead and read through this scenario for me. So before we even write the objective quantity, what are our unknown values in this problem? The number of tablets. So we have two different models, right? So number of $250 tablets and the number of $400 tablets. Okay. All right, so the first open space you have is the objective quantity. When we're looking at an objective quantity, I want you to look for the word maximum or minimum, or the word optimize. So you have three choices: optimize, maximize, or minimize. Do you see any of those words? Okay, I see maximize profit. Okay, so your objective quantity better deal with profit. Okay. How much profit does the $250 model give us? Okay, the $250 model yields a profit of 45. So our objective quantity, I'm going to write P for profit. We get $45 for every X tablet we sell. And the $400 model yields a profit of $50. So plus 50Y would describe the profit that we're getting from each $400 tablet. Okay? Do we graph the objective quantity? That is never something that we did. We write it at the beginning and we save it for the end. Okay? So let's write our constraints. Okay. We're talking about tablets. What are the first two constraints we're writing? Okay. We better write in that x is greater than or equal to 0 and y is greater than or equal to 0. Okay. All right. It says something about the total monthly demand will not exceed 250. The total monthly demand will not exceed 250. Does that mean?
Less than or equal to.
Okay. Well, it means less than or equal to 250. What should be on this side? Okay. Number of tablets plus number of tablets should be less than or equal to their demand of 250. Okay. It also says they do not want to invest more than $70,000 in inventory. They do not want to invest more than $70,000 in inventory. Okay. What would we write down, Jacob?
250x plus 400y is going to be less than or equal to $70,000.
Okay. And I'm not going to write the dollar sign just so it won't be messy, okay? But each X tablet costs $250. Each Y tablet costs $400. And they, in their store, do not want more than $70,000 in there. Okay? Have we used all the sentences? All right. So, I'm going to graph my first two constraints. Here they are, right? Okay, I beg of you, do not take these two inequalities and graph them in slope-intercept form. I really don't want you graphing y equals negative x plus 250, plotting 250 going over one down. No. Okay? And we have, if we look at this line, I think we can all agree we have an x and y intercept of 250. Should I count by ones? No, that would not be smart. What should maybe I count by instead? What? 50s? 25s, 50, what do you think? 50s? Okay. So, let's see. 50, 100, 150, 200. This is 250, right? Okay, so I'm going to graph this equation in red, like so. Okay. Your calculator is probably going to need to help you with this next one. Okay. I'm going to make a mental note that with this red line we just drew, well, I probably should label it, right? X plus Y equals 250. We are going to want to shade towards 0, 0. Okay? Help me out using your calculator. If we plug a 0 in for X and we have 400, Y equals 70,000, what would our Y-intercept be? 70,000 divided by 400 would be what? 175. So let's see. Okay, and then if I plug 0 in for Y and we have 250, X equals 70,000, what's our X-intercept? What? 280. Okay. And it appears that this one would also be shaded towards 0, 0. So our overlap, remember we're in the first quadrant, is going to be here because they're both going towards the origin. Okay. We're still into what we were doing yesterday, right? How many vertex points do we have?
3,
I disagree.
4.
There are 4. I really need you to remember that x equals 0 and y equals 0 are 2 of your lines. That's an intersection right there. It's the easiest one, but I will take off points if you don't do it. 0, 0 is a vertex. Okay? And then the 2 of them we should have labeled. Okay? This guy right here. Good thing I labeled that number so I don't have to find it again. That is the coordinate 0, 175. This coordinate I have labeled. It's the coordinate 250, 0. Our graph is probably not going to be very helpful with that coordinate. You are going to have to do substitution or elimination. We're sort of running out of time, and I think that we would run out completely if we tried to do that. So I will tell you, if you take these 2 equations and you do substitution or elimination, we would get the coordinate 200, 50. I'll just help you out with that. Okay, now what do we do with our vertices? Okay, we wrote this objective quantity right here. All right? Because we're trying to answer the question, how many models should we order to maximize profit? Okay? So 40x plus 50y. Okay? Our profit of 45x plus 50y would give us a $0 profit here. Okay. Not surprising. Okay. Our profit of 45x plus 50y, and this is where your calculator is really going to have to help you, will give us a profit of what?
11,250.
11,250. Okay. 45x plus 50y would give us a profit of
8,750.
okay, and then this one,
I got 13,750.
you seemed unsure of that. Are you confident in that? Okay, do you agree with him?
45 times 0 is 0 plus 50 times 175. Isn't 50 times 175 8,750? Not 11,200.
Oh, did you tell me these to me backwards?
Oh wait, yeah, I took it back.
These two are just backwards. That is an easy. Whoops. Okay. Maybe that's not going to be. Okay. So this should be next one. 8,700. What was it?
50.
50.
Yeah.
Is that better? All right. Nathan, you had them. You were plugging and chugging and ready to tell me. Thank you for participating.
For the last one, I got 11,500.
Same. 11,500. Take 45 times 200 plus 50 times 50 again.
Oh, I took 45 times 250.
Okay. You got 11,500? Okay. So what's our answer? For a max profit of $11,500, we would need to order 200 how do we want to say it? How much are they? $250 tablets and 50 $400 tablets. That would be our answer. Okay? You can't just leave it there. You have to tell me what the coordinate means. Or tell me what the number means that we got out of it. Okay? Now, do you think that on your test on Tuesday, in 1 week from today, this is going to be like a 3-point problem? No. You are going to get points for identifying your variables. That's 1 point. Objective quantity. That's 1 point. Constraints could be 2 to 3 points. Your graph, couple points there. Okay, probably 2 points for the inequalities, 2 points for the graph, 2 points for your inequality, or for your vertices, a point for plugging them in, and then a point for making your decision. I mean, we're talking about like 10 or 11 points there on that problem, okay? I am not telling you that to scare you. I just want you to understand the reality that there's a lot of work in this problem, okay? So not doing your homework, not trying to do your homework, or not trying to understand this really isn't an option for you, okay? Do what you can in your homework, and we're going to work on this again tomorrow, okay? We'll come back to it. Carly, when you went over those, did that answer the question that you had?
I think
Okay. You want to talk about that sometime? What time? How about you come at the very end of your time, and then you can do it a few minutes later. Will that work, or do you want to come at the end of one? What would be better? Okay, let's do that. Okay. Okay. Because you had one that you were going to
I
do.
just had this one.
Okay, perfect. looks beautiful.